I can't travel. Hello, good morning to all of you. Thanks for coming for this presentation. I appreciate your time. So, friends, I wanted to understand that in this hall, how many of our engineers and architects? Can you raise your hand? Engineers and architects. Wonderful. And how many of you are from the actually doing the construction, I know a lot of engineers are on the site also. Thank you. So today, our industry is facing a major challenge. I don't know how many of you are happy that you have a 9-to-5 job, Saturdays and Sundays off, getting vacation, getting bonuses. Wherever I go, we find that our industry is in trouble. We have not changed over the last 100 years. If you look at automobile industry, if you look at any other industry, they have developed, they have evolved, their productivity has changed significantly. But in our industry, the productivity is almost 1% gain per year in the last 20 years. That was the McKinsey report that I read. Whereas in other industry, it is like 3.5% to 4% every year. So our industry needs a lot of changes. Our industry needs a disruption. Our industry needs a paradigm shift. And today, I'm going to talk about that. What can we do to improve? And I'm sure already a lot of things are happening. Just wanted to share some of my experiences worldwide. So at Pinnacle, we started our firm 30 years back. I founded the company, and our vision was to bring efficiency and certainty into construction. You see, in our industry, if you see any project, there are at least 40 to 50 engineers and consultants. If it's a complex project, there are structural consultants, mechanical, electrical, facade, landscape, all types of consultants. And we work in our silos. And we are all located at different geographies. So to bring everybody together, to ensure that we collaborate, we do value engineering, we optimize our projects, it is very, very important that we bring certainty and efficiency in the project. With that vision, we started Pinnacle 30 years back, and I wanted to share some of the experiences. As I said, today we are located in 7 countries. We have physical offices. We have got production centers in India, 3 production centers. Now coming to the construction challenges that we have today. First of all, the designs are becoming complex. Today, if you look at an airport, if you look at a stadium, if you look at any commercial building, my friend from Arup, he will agree with me that now with the technology, the kind of services, if you look at a hospital, the kind of specialty hospital, there's so many types of gases, steam, water of different temperature. You need all that. So too many stakeholders. Today, as I explained, large number of services. The number of services that we have to coordinate and build in any project is increasing every day. The schedules are becoming shorter. In Ireland, there's so many projects going on. Intel and all the other companies, they want it tomorrow. Like, they want the projects to be completed as soon as possible. The cost pressures, we are all under the pressure. The costs needs to be reduced. And of course, the sustainability angle is getting more and more complex. So these are some of the studies, I don't want to get into more details, but the fact is that our industry needs some change. This is the traditional workflow that happens in our industry. And since many of you are from architectural and engineering background, so we know that it's a flow from architects to structural to MEP engineers, and it keeps changing. Somebody changes the door, somebody moves the wall, somebody moves the duct, and it has an implication for everything, the All our calculations change, all our structural calculations change, all our electrical calculations change. So we need to again keep going, and it's a chaotic world. So what BIM is doing is that we are bringing everybody on the same table. All of us are connected online. All of us are making sure that we know there is one single source of truth. There is one model where everything is there. Any changes, it is updated on the model. So there is no revisions. There is no revision management issues because there is one model and all of us are directly working on that model. So today, when we talk about, like, our company provides services all around the world. We are 2,300 engineers and architects, done more than 7,500 projects. So today, my objective is not to talk about my company, but my objective is to share with you some of the best practices, share with you an actual example that on a very, very complex project that I'm going to talk about today, how did we change it? How did we make sure that this project was completed in time? So in BIM, there is a pre-construction, there is a construction, and there is a post-construction. You know, Abraham Lincoln, he said once that if I have 6 hours to cut 6 days to cut a tree, if I have 6 days to cut a tree, for 4 days, I will only sharpen my axe and I'll use only 2 days to cut the tree. So that is a smart way of working. So today, we need to ensure the pre-construction is the most important part of today's, I believe, of our industry. We need to make sure that all the activities, we have planned everything, we have created all the drawings, we have looked at the logistics, we have looked at the material required, we have value engineered, so that after pre-construction, before we get into construction, we have an as-built model. So all the projects that we work on, we want to make sure that the as-built model is there, even before you start construction. And there should not be, ideally, there should not be any changes during the construction. So that is our goal, and that is what we are trying to do that in this industry. So if you look at the integrated workflow, so what we are saying is that once you design, the concept designs, once it is over, then today you have one model where everything is integrated. And then today the good thing is all the analysis software, they talk to the model. So you can interface, whether it's structural engineering, whether it is illumination, whether it is pump head calculation, whether it is voltage drop calculation, you can do all that. And it is getting better every day. So there are hundreds of software, which are now working together with your coordination model so that you are able to value engineer, you are able to perfect that model even before at the construction. So you exactly know that. So what we do, let's look at the mechanical design, So at the pre-construction, and I'm talking about all pre-construction, that in the pre-construction, you need to have the engineering. So what you do is, whatever the air and water balancing, whatever the load calculations, because you know exactly what are the walls that you have. So you are able to exactly design, see the load calculations. You are able to create the pipes, duct sizes, all engineering calculations sitting in the model before you start construction. And this is a typical design workflow. Don't have time, but I would like to see that how we do all these design calculations, starting from the architectural input, load calculations, tonnage calculations, air terminal selections, airflow calculations. And friends, the biggest advantage is today when we design, traditionally when we design, what we do is we keep a lot of buffer, So an electrical design engineer will keep a 20% buffer for the transformer. A pump that you are designing, we have a lot of engineers here, a pump that we design probably will keep 15 to 20, and people have honestly agreed that, we even keep 25% buffer because we don't know how many bends will be there in the finally, what will be the length of the total pipe and the bend, so I cannot calculate my pressure drop exactly in the beginning. So we are talking of a paradigm shift. We are talking of a disruption where we are saying at the design stage, I will give you the exact number of the bends and the Ys and the Ts in the circuit, and you should be able to give me a buffer of not more than 5%. So that is the challenge, and we are doing that, and I think that is the disruption that we need to bring in our industry. Same thing with the electrical design, you can do, sitting today, the software is becoming more and more powerful. And we have developed several add-ins to even improve the capabilities of the software. So you are able to do all the designs, electrical, whether it's conduit sizing, cable tray, cable sizing, panel, everything should be perfect. Same thing with the plumbing design. I'll quickly skip that. Now, I wanted to discuss with you FIFA World Cup Stadium. So how many of you are soccer fan in this room? How many of you? All of you, right? How many of you will be in Qatar for the FIFA World Cup? So this is the Flagship stadium where the finals will take place. And this was done by Pinnacle. And I'm proud to present this from LOD 200, the concept design till the handover. And I want to share this today with your team because I believe in talking what can be done, what has been done. So this is what I would like to share with you today. So this is, as you can see, very 92,000 capacity, 40 months, and out of that, 24 months was in COVID. So there was, you can imagine, it was the worst timing of the project. So the last 2 years, 21 and 20, so we effectively had only 20 months to do this project. And this project, as you can see, 13,000 ton capacity because this is completely air-cooled stadium. So if you see the number of ducts and pipes below the sitting, spectator, below your seat, there are all ducts and pipes going in the stadium. Unique. I don't think you have this anywhere in the world. So the challenge increases even more. 150 material suppliers, 900 type of materials. Let me quickly show you a video. So if you look at this stadium, it is extremely complex. If you look at the facade, the outer facade, look at this stadium. Before, he's my project manager, Leonidas, and the planning, we virtually 200 people from our company worked here for 4 years during this entire duration of the project. And in the beginning, as I said, we planned, because the 40 months, what will happen every day? You can say that okay, after 24 months, on 1st October 2021, how will the stadium look like? We had planned it. Every, huge amount of, and this is the actual photographs that has been taken from the site, and I will discuss more details of this project. Most of it was precast. And can you believe it? This $2 billion stadium will be dismantled next year. This was just because they've got 8 stadiums in Qatar. They don't know, they're not going to get another FIFA World Cup for next 10 years. And so they're going to convert this into a sports arena. So this whole thing was designed so that after next year, we can actually dismantle it and create a sports arena and different, and it's already planned like that. So imagine the kind of 80-meter steel trusses are being moved up. And I'll explain to you how did we make it possible using BIM. It was amazing journey, amazing journey. We can ask questions. Luke, I don't know whether the questions are allowed, maybe some interactions while we go on, if you have time. Yeah, okay, we have the panel discussion. Okay. So look at the site logistics. There were 130,000 items in this stadium, and all procured from different parts of the world. 30,000 workers working on the site. 30,000. Imagine all the 30,000 people could work on the site without any interference. They all had their clear drawings with XYZ coordinates. They don't need to talk to another, just do your work, make sure that you are following your drawings. That's how this project became possible in such a short time. So I'll show you some very interesting innovations that we used for this project. So if you look at the architecture, the concrete structure, the mechanical, electrical, and plumbing, what we did for this project, as I said, there was one single model. The whole project, nobody can show me a 2D drawing which did not come out of the model. 35,000 shop drawings came from one single source of truth throughout the project. We had no options because all the consultants, all the contractors were located at different places. And there were 1,400 submodels, 220,000 assets which we handed over to Honeywell 3 months back, that okay, now this thing is, so the Kobe sheets for 220,000 assets, back to you. Like what we did, I mean, I really cannot go through all the analysis, but every aspect of the stadium, whether it was light, whether it was electric, whether it was plumbing, whether it was simulations, various types of, because this is FIFA standards, which are very, very strict. And FIFA have their own requirements. And in this project, we did all on the FIFA standards. Now, given the shortage of time today, I would like to more focus on what we did during construction. And we extensively used laser scanning in this project from the day one, when the construction started. Now, what did we do with that? First of all, we did the progress monitoring. Because it was a very critical, so we had the 4D model that for the next 40 months, how will the stadium look every day? How much construction should have happened on that particular day? So if it is 13th October, what should be there? So what we did, so we created that, and now every day we would scan the progress and we'll compare that, okay, these are the areas we are behind, these are the areas we are ahead. So we had a team sitting at the site and getting this data. So every week, not every day, I would say I'm wrong. So every week we'll compare that and we'll share it with the management, share it with the subcontractors. That guys, you are behind. What will you do to come up on the speed? Okay, sorry. So then there's a deviation analysis, which I will talk. This is the most interesting part of that. Slab slope analysis. For example, most of our constructions, the problem is that we design, but when somebody is casting the slab, there are, the slabs are thicker somewhere or slabs are, thinner somewhere. The columns are not exactly, it is not humanly possible to make everything accurate. Or the steel structure, when you have an 80-meter steel structure hanging, there would be some deviations which nobody can model, right? So you have to now adjust to that. And I will come to the details on that. Even the precast leveling and alignments, the stockpile calculations, we help them to measure the bills, approve the invoices of the contractors, what is the progress, how much of sand, how much of gravels are there on the site, that how much of earthwork was cut, that was all done using laser scanning. So I'll take one of the aspects here. Most of the steel in this case was fabricated in China. So imagine if you fabricate a steel in China, and these are huge steel, right? 30 meters, 50 meters span, you saw in the video. And if it comes to the site and you realize that it is not exactly what you want, there's some changes because of the site conditions, or the contractor has goofed up, he has made some deviations. So what you need to do is, so then the time is lost. You cannot send it back to China from Qatar, right? And it is true with any site. So what we would do is, okay, so let me go to the next level, what we will do. So this is the fabrication shop in China. So what they will do is, once they fabricate, they will scan it and send it to us on the site. Now, at the site, we have the as-built model going on. Like every day, we are scanning all the concrete structures and the steel structure. So we know what exactly is the situation at the site. So these guys will first scan it and send it to us. We will put that virtually on the model, tell them what are the deviations, they will correct that, and then they will send it back. Does it look interesting? We actually did that in this project. Then, when it comes, the trial assembly, when it comes to the site, right? Sometimes you cannot carry 80-meter assemblies, right, on the ship. So you're bringing sub-assemblies. So once we assemble the sub-assemblies, once again, we are scanning, we are looking at the deviations, we are putting it on the as-built model, and we are checking what are the differences, because the embed plates that I was talking about, you have a tolerance in the embed plates, right? Few millimeters you can do that, not beyond that. So you have to, now what you do is, look, what in man hours, it would take 21 hours for you to actually do a survey of these embed plates and see if things are in order. With laser scan, we could do it in 3 hours, and the best thing is, this laser scan could directly go into the as-built model and check that. So this deflection monitoring and the control of long span structures was done at the site. So we don't want to lift this steel and then find out that it will not fit in there. Everything was being done on the ground, scanned, so it was like in one go, it will happen, it will work. Even the virtual erection of the compression rings, like this site, as you can see, these long structures, when you're putting it, there could be deviations at various places. So the end result is that it has to be the perfect. This is the facade ceiling clashes. Even the facade was very critical, because the structure is so irregular that when you are taking it up, every piece you have to align with the existing site conditions. So every piece was aligned and then lifted. Every piece was aligned and then lifted. This is how we achieved in this project. Another thing was the facilities management, because it is very, very important. And during this COVID times, it was paperless inspection. There were 72,500 inspections. Fortunately and unfortunately, inspections happened when there was COVID. So the inspectors will not go on the site and risk their life. So they accepted it. Otherwise, I don't think they would have accepted. And they're today very happy, because all 72,500 inspections, we could send those inspection reports to all the stakeholders and get things approved. Thank you. I think, do I still have time? We have 5 minutes? Okay. Yeah, so any questions from the audience will be appreciated. Any observations? If you have done something similar, we can talk about it. Yes, please. So he's asking that, we have so many assets and it's a complex thing. So what software platform we use for this? Okay. So good question. See, when you have such a complex project, then you really need to plan your Revit model. You need to break it up into such sub-models, because ultimately everything has to be connected together, right? So sometimes if you do an analysis, I need all the 1400 sub-models to be connected together. So it was loosely tied up so that when you need, you tie up everything. So the work sets are created, it is broken up in such a way so that independently you can work, and there's no, so there is a compromise between the speed and the numbers of the models. But it was all done on the Revit, and we have a very strong R&D team. So they play around with the model. They decide that how do you break it up so that everybody, and not only we, all the stakeholders had access to this model. One model on BIM 360. So the structural engineer, the MEP engineer, the consultants, the owners consultants, everybody was accessing this model, and it made our life easier because a lot of approvals in Middle East, those who have worked, I know, Hemant, you will know that. So there is a lot of inspections by the consultants, right? Especially the owners consultants. If there's a scratch on the duct, on the duct insulation, they will probably reject it. So if you draw a line on the duct insulation with a pen, they'll probably reject it. So this is very important that, through this, everybody can see it. So the RFIs gets resolved, all the questions get resolved much faster. Okay. So Luke, that's a good question. As I said, we did not have the luxury, although I preach pre-construction and that the model should be over before you start construction, but in this project it was not possible. They jumped on the field, immediately because of the size of the project. So while the design was happening, we were also updating as the material submittals came, as the various items got approved, we kept on updating the model. And there was one model. So the advantage was, like, now you approve that this will be the transformer, these will be the valves, will be the... So we kept updating that and making it more and more accurate. So moving from LOD 200 to 400 was a continuous process. And as per the site requirements, we had to create the shop drawings because they have to, the whole thing has to be precast. So you have to keep creating the shop drawings as per the site priorities, right? So it was not, I would say, the most ideal execution that I would love to have, but then you have to compromise. Like in this kind of stadium, in the beginning, the material management team is not able to approve all the material to you because there's a FIFA standards, there are like availability, cost, all kind of considerations are there. So the model is continuing and the shop drawings is following it. So this is how we worked on this particular project. How many? Oh, okay. So there were 35,000 shop drawings, and I would say mostly the shop drawings were produced, most of them, 90% of them was done in a year. So if I've got, let's say, 300 days working and 35,000 shop drawings, so you can imagine 300 drawings getting produced, 100 drawings produced every day. 100 drawings produced every day. And they all need to talk to each other because 30,000 site workers are working on the site. And I went to, and I keep going to this site, it's my favorite place, and I spoke to, and we have a lot of testimonials from the site managers, the project director. And I asked him, what did you benefit from BIM? And he told me one thing, that my 30,000 people could work together at the site without talking to each other. So we brought certainty on the project. That yes, if you follow the drawings, then you don't need to talk to each other. Just do your work. Thank you very much.
Thank you for that, Bimal. I think that was very interesting. If anyone has any further questions, we can ask at the end when we've got the panel discussion as well. I'd like to now introduce Igor Adlersberg. I believe I'm saying that right. He's a tried and tested entrepreneur in the industry, and he's going to tell us a bit about BIM life hacks within engineering and the BD development.